Hello everybody, I hope you're having a wonderful evening. This video is going to cover your small intestines through to the exit of food, essentially. So we're going to cover your small intestines and your large intestines here. Right? So we're going to go all the way through. When we left off, we had left off talking about your stomach, and your stomach was slowing down its digestion. It was halting its production of hydrochloric acid, and it was dumping about 3 milliliters at a time of chyme into your small intestines. Right? The beginning part of your small intestines serves a couple of different functions. But first, we're going to talk about the different regions of your small intestines. Right? A lot of chemical digestion, like anything the stomach didn't do, so almost all chemical digestion is going to happen somewhere in your duodenum, and most absorption of things happen in your small intestines, right? So your small intestines are super important. All in all, your small intestines are about 18 feet long, right? If you've died, they may be closer to 30 feet long. Your small intestines are huge. They're the majority length of your system. But they're only about an inch in diameter, right? But it's divided up into 3 sections. So you have the duodenum, which is that first section. The duodenum is the shortest area, only about 10 inches, and it is the thickest region. Then you have the jejunum, which is the second area. It's where most of your digestion and absorption is going to occur. It's also the featheriest. It has the most inner folds when you're looking at it through medical imaging. And then the ileum is the last 10 to 12 feet of your small intestines. The ileum is going to contain a lot of lymphatic nodules called Peyer's patches, as well as try to catch the remnants of the parts that the jejunum did not finish absorbing. Right. So those are the 3 regions of your small intestines. Your small intestines, when we look at them on the insides, they have these little growths that will look feathery under a microscope, or like little bitty tentacles called villi. And each of these villi have little villi on top of them called microvilli. All of these folds and waves and little tentacle growth looking things are there to increase the surface area of your small intestines. And all of these villi are covered in cells that are dedicated to either creating enzymes and chemicals that will help break down food or absorbing the food themselves. And each of these little villi have a lymphatic duct in it, as well as a capillary system. That lymphatic duct in them is called a lacteal, so that they can absorb the most nutrients possible, but also double check those nutrients via the lymphatic system for foreign invaders that you may have eaten. Right? So once again, this is going to look feathery under a microscope. See, it's feathery. That's a close-up of your villi. Right. Oop. So when we're looking at that's generally speaking a decent amount of stuff that you need to know. In the duodenum is where the liver and the pancreas are going to meet and secrete bile into. We're going to talk about that a little bit, and we're going to skip our large intestine bit for a little bit so we can discuss this further, right? And we will talk about bile in a little bit, right? But bile is made from some of your accessory organs that we will discuss. And bile is going to empty into that duodenum area. So we have this lovely image here. We have liver, gallbladder, stomach dumping into your small intestine bile, right? So your stomach is only going to release about 3 milliliters of chyme at a time, right? So chyme is going to enter the duodenum, and that's going to cause the duodenal enteroendocrine cells to release something called cholecystokinin, or CCK, and secretin. Those are two localized hormones that are going to be released with bile here. Right? Or those CCK and the secretin are going to enter into your bloodstream when your duodenum senses that you have let your stomach has released stuff to it. Right? At that point in time, the CCK and the secretin are going to be immediately reabsorbed via this lovely blood system here into the pancreas and the liver. And bile salts are going to be stimulated to be produced in your liver. Other CCK and other digestive enzymes and pancreatic juices that are enzyme rich are going to be stimulated in your pancreas. CCK is also going to release in your gallbladder and force your gallbladder to release the bile that it is holding onto as well. And during the cephalic and gastric phases, the vagus nerve is going to stimulate your gallbladder to weakly contract. And all of this is going to start dumping in through this bile duct here into your duodenum. Right? Remember how we mentioned earlier, or in your last video, that as your stomach is dumping the chyme into your small intestines, your stomach is built to handle stomach acid, but your small intestines are not. One of the jobs that bile has two main jobs. That is digesting fat through bile salts, so breaking down fatty lipids and that kind of thing. And it is to neutralize stomach acid. So by slowly dumping chyme here into your small intestines, this is the trigger mechanism to send CCK and secretin to your pancreas, gallbladder, and liver to release the bile salts and the bile into your duodenum so that your stomach doesn't burn your small intestines. So bile is going to neutralize the stomach acid of those 3 milliliters at a time of chyme that your stomach is dumping into the small intestines. And it's also going to, that CCK is going to help start breaking down fatty lipids. Remember, I also mentioned, like in your last video, that the sugar or carbohydrate-rich chyme is just going to kind of keep sludging on into the rest of your small intestines, whereas the fatty chyme is going to end up getting like stuck and stay here for up to 6 hours longer. That's why, because your bile has to help, the CCK here has to help break down your fat. So fat and eating fat is the most it takes the most energy to digest fat, and fat will take the longest to digest in your body, which is what I'm getting at here, right? That's a purpose of your small intestines, to start breaking down the fat with the bile and the chyme, and that's why the fat digestion process really starts in the duodenum instead of the protein breakdown in the stomach or the sugar breakdown in the saliva. Right? But everything is going to move through your small intestines, and then the good stuff absorbed with the bad stuff being propelled on, and that's going to bring us to your large intestine, right? So your large intestine is the next thing we need to talk about, right? Your large intestine here is about 5 feet long, but it's 3 inches in diameter. That's why it's the large intestine, because remember, your small intestine was only 1 inch in diameter. So your large intestines here are wider and larger. It's going to begin at an area called the cecum. So here we see your small intestines dumping into your large intestine at the ileocecal valve in this image, into this region called the cecum. The cecum is the area that has the appendix hanging off of it. You have a lot of bacteria and good gut bacteria in your large intestine, because bacteria helps you break down certain nutrients in food that your body can't. Right? So we have a nice symbiotic relationship of this. Your appendix serves as a, how shall I say, bacterial reserve. But if your appendix ends up with bad bacteria in it and it gets infected, you have to have your appendix removed. Doctors are not going to play with that. They're not going to give you antibiotics to see if it passes, because your appendix is directly attached to your large intestine. And if your appendix bursts, that means you just had a hole burst into the sides of your large intestine. And all of that, what was good bacteria that happily lived and helped you digest food in your large intestine, then gets out of your large intestine and goes septic and starts infecting the rest of your insides. Considering the fact that this bacteria is on your waste product, you don't want that to happen. E. coli is one of these bacterias. And I know you guys have heard about E. coli getting into food, and that causes a lot of food recalls. E. coli is perfectly fine when it stays in our large intestine and when we can be happy that it is in there. If we ingest it, so if we re-eat E. coli, or if you end up with a hole in your large intestines and it gets into your bloodstream, it will poison and kill you. Which is why we're so big about food recalls if there's been a mishap at a food packaging plant or something like that. But yeah, your appendix will be removed if it's infected. They're not going to play games with that. The cecum is this area of the large intestine. If you are one of my students that wants to go into veterinary practices, the entire purpose of the cecum as part of the large intestines is to help digest fiber. We are omnivores as humans, so our cecum is not that large. One of the reasons why we should eat more fiber is because fiber is going to glob onto the waste byproduct in us and sort of just help move it along out of our intestines and out of our digestive system. It sort of acts as like a toothbrush for our insides. But other animals like cows, koalas, whatever, have rather large cecum because they have to digest all the leaves and that kind of thing. So that's the purpose of a cecum. If you get into veterinary medication or veterinary medicine, herbivores tend to have a much larger cecum than we do. Koalas have a huge one compared to their body size. But fun fact, just so you know. But yeah, you then force all of your fecal matter upwards. Through the ascending colon. It hits the top right corner, which is your right colic flexure or your hepatic flexure. It'll go across in the transverse colon, hit the left colic flexure, down the descending colon, through the S-shaped colon, which is your sigmoid colon, and then get to your rectum. And then the anal canal after that is where things terminate. The purpose of the rectum itself is about 15 centimeters long. The majority of your large intestines is like 5 feet. Right? You have a decent amount of mucus in there. But the mucosal layer this time is simple columnar. So it's all shaped like columns, epithelial. You're not going to have any circular folds or villi in the large intestines. That's not their job. You are going to have lots of little intestinal crypts with goblet cells that make a lot of mucus for secretion. And you have a bunch of lymphatic tissue in here. The job of your your large intestine, the job of your large intestine is to reabsorb as much water and salt as it can. So your small intestines broke things down and got the nutrients out, or most of the nutrients out. Your large intestine's job is to attempt to catch anything that the small intestines missed while it is taking what was a liquidy milkshake-like substance and reabsorbing water from it to dry it out to the point where it is the fecal matter that we excrete. Right? The bundles of section areas of your large intestine are called haustra, and the tinea coli is the ligament that goes all the way around it that holds it up and in place. right? But yeah, so the purpose of your large intestines is going to be to give a home to the bacterial flora that will help digest the things that your small intestine could not. And then it will absorb the nutrients from that additional cellular digestion, as well as reabsorbing water and that sort of thing. This is why you synthesize vitamins B and K in your large intestine. And your large intestine sort of focuses more on the plant material that we may eat, that we lack digestive enzymes to get to, like cellulose and pectin and that kind of thing. A byproduct of many of these good bacteria breaking down the food that we eat kind of thing, especially if you eat beans and whatnot, happens to be methane gas, right? You actually produce about 1,500 milliliters per day of methane, which is, of course, the gas that we expel. Right? Your fancy medical term, by the way, for fart is flatus. Right? So your body's end goal is to take the fecal matter that came out of the small intestines and reduce it to be about 75% water and 25% solid, so it has more form when you are releasing it. Right? It's going to take 12 to 24 hours to form this fecal matter. So it takes a good long time for food to digest and go fully from mouth to anus. We're talking like at least a day to go from mouth to exit, right? Those haustra are going to contract about every 30 minutes to mix residues and promote absorption of things like waters and salts while pushing things along. And then you have mass movements of all of the muscle kind of like pushing everything along, that last about 15 minutes, 2 to 3 times a day, to help move things forward. Usually that is triggered when you eat and your stomach senses that there is food, or your duodenum senses that there's food. So to make room for the meal that you just ate, you're going to have a mass movement pushing the fecal matter all the way like around your large intestines. Right? But you have small movements like every 30 minutes to just keep things moving along slowly at a slow pace. Right? Sometimes there are imbalances here, right? As you get older, as you strain the muscles, this is a condition that not the healthiest people or our elderly tend to have. It is called a diverticula, right? Because sometimes you end up with little pouches forming on your large intestine, especially if you are straining the muscles to relieve yourself of that waste. And part of the muscle will just stretch out and you'll end up with like a little pocket on the inside of your large intestine. Right? That is called a diverticuli. So those are small herniations in the mucosa of your colon. Excuse me. Diverticulosis is the condition occurring mostly in the sigmoid colon when you have a bunch of them. So this would definitely be diverticulosis. You can see this individual has a number of these diverticuli or pockets. If you have diverticulitis, it means that your fecal matter is getting caught in these pockets and then becoming infected, which is not good for anything involved because that's going to make your large intestine swell, and it will make things even harder to pass through if things are swelling because of infection, which will make going to the restroom even harder, which will increase your body's accidental production of these diverticula. Plus you have an infection on the inside. It just won't be pretty. However, this kind of thing just happens naturally over time, so it affects about half of the people that are above 70 years old. Basically, the best way to combat this is to increase your fiber or your bulk in your stool, so that, like, when you eat more fiber, the fecal matter has more fibrous stuff to hang on to, so it exits your body better. Right? Defecation is the last step of this. That is getting rid of the waste byproduct. All of it compounds in the rectum, and then when the rectum feels stretched out and full, right, you have some parasympathetic defecation reflex and two sphincters here, an internal anal sphincter and an external anal sphincter, that begin to feel the pressure and be pushed upon by the fecal matter that is stored in your rectum. And that is when you know, hey, I need to go use the restroom. You have voluntary control of your external anal sphincter. This is what we potty train for. We have control over that. You do not have control of that internal anal sphincter. That's going to be the first one that starts feeling the pressure of, oh, I really got to go. And that one is an involuntary response. So listen to that involuntary response. Don't play games. Just go to the bathroom. Right? But yeah, then you will relieve your waste, clean up, and that's basically the full pathway of food through your alimentary canal. In your last video, we're going to talk about the accessory organs beyond your mouth. I know we've already talked about your tongue and teeth and that sort of thing in your mouth video, but we're going to discuss your liver and your pancreas and disorders that can come from them when things go wrong in your last video. But this is pretty much, we've followed food from your mouth through your entire alimentary canal at this point, and that was your large intestines, my dears. So I hope you have a wonderful, wonderful day.